share some of the my experience of steel in the construction industry. I have been associated with the National Hydropower Corporation as a designer for underground structures long back in 82 to 84, and subsequently I did lot of work in the defense. So some of the works, like we were just talking about the data centers, the first such works which are mostly underground, and they have to deal with the dynamic structure loads, and because their safety requirements is very high. It is very recent that they will start coming in India, but they have been coming elsewhere for long, and because lot of data is stored there, so the maintaining the temperature, maintaining the dynamic safety of the structure under the very severest of the earthquake, much more than what we do for the normal buildings and the dams. So I had the experience long ago for doing that, and then subsequently I came to metro, starting with the airport line in Delhi. I spent around 10 years in Delhi metro, and for 4.5 years I have been here. So coming to the steel as a subject, see, in the metro projects, typically one third of the civil structure cost constitutes steel, and typically in the overall project cost, one fourth, 25% is the consumption of steel, whether it comes in the form of rolling stock or the rails or the third rail or the steel, temporary steel. In fact, in underground structures, the consumption of steel goes up to 40% of the cost, because around 10% cost is the temporary steel. So, and then when we see where do we start today and where we want to go, that is the aim of the conference. So, in the context of the climate change happening, the sustainability requirement, the most important thing is that where the steel fits into that, and are the steel grades and the quality of steel and the research and development in the field of steel is fitting into the entire scheme. When the RCC came in, some around 100 years ago, before that they were all steel bridges or the then reinforcement concrete came in. And the idea of reinforcement concrete was that if we go into the basics, the steel, what we plan in the designs, 550 grade. 550 grade fit for dynamic load. So 550D, that is the typical. And if I go to the granite, granite also have strength 600 to 800. So in the compression, it is mostly same. But what do we do with I do with the granite? I break it into the pieces, I make the aggregate, and after making the aggregate from that 600, 800 strength, I try to achieve 60 to 80. So means when I destroy a natural material and I want to go to back to the natural strength of it, I only achieve 10%, maximum 15%. That's all by bonding with the cement. Now, when we come to the steel, we are achieving a much higher strength. And so, in the process, when we take out a ore from the earth, in one side I take out the aggregate, on the other side I take out the steel. I am able to retain its maximum strength. So that puts the simplest logic that the energy consumption or the efficiency of the material of steel is much higher than the concrete. And it is now the only issue is, are we able to use it? Now here is where we are mostly lacking. When it comes to the typical designs which are used in construction, what I have experienced is that some of the systems have been developed very nicely by steel industry, and they are very cost efficient for scaffolding, for the for like say rails, uh, train loads. They are very efficient structural member. So they are used worldwide. Scaffolding is used worldwide, Doka steel and other kind. Very good solutions. There are solutions which are like say for piles. There are very good solutions, but they have not become popular in India because of simple reason. It is not available off the shelf. Now it is not how it can be available off the shelf if the industry takes that charge.
No, I'm asking.
Now, today what happens, the small suppliers, the small stockists, they take the charge. So, whenever a underground construction person goes in the market and he wants to have the steel piles or he wants to have the other earth supporting structures, they are not readily available. Now, as a solution, what happens? The field engineer or a detailed design expert designs particular to that situation. And when he designs particular to that situation, that is site specific. And even in one project, say I have one station in Surat which is 35-meter deep. I have another station in Surat which is only 17-meter deep. So there will be site issues. I use it, but then I have to throw it. Then it has to be recycled because there was no modular solution for most of our requirements. So one of the things which is developing fast in India is the underground spaces because cities have become crowded, whether it is metro, whether it is basement of building, whether in Delhi you are now allowing up to three basements and the redevelopment. So underground structures are going to be a part or whether they are data centers for various reasons. So there is a requirement for industry to identify the opportunity in underground structures, temporary works, and make them as a standard product. Like in the other area is the efficiency of the structural system per se. Now, the long ago, when the steel usage was being promoted, so Tor Steel Tata Foundation came up with a very good book in some 70s, and to the efficient design. Subsequently, in last 40 years, there has not been any such a great supportive book which suggests solutions for most of the situations. So what actually happens is when we go around the city as engineers, all of us will easily notice that there are many inefficient uses of the material. Now, how it affects? One way can be, it leads to more consumptions. We are okay with that. At individual level, that feeling will come. I am able to sell more material for this. I am happy about it. But at industry level, in the overall concept, it is very uh, retrograde. So what will happen? At large, people will not use it. So when the solution is coming, which is cost effective, then it will be used across the board. So there is a requirement that there are efficient designs available. For the last 10 or 20 years in airport, Delhi airport, Mumbai airport, the roof structures, very efficient structures, like one of the figures were being shown, the joint designs, where so that the forces gets transfers, most of them in the tension stage, not in the compression stage, they have come up. But they are being used only by certain, big groups of in construction like L&T and others who have their in-house design experts. Common man is unable to make use of that. So if those designs are available through any industry norms or through industry publications or they are pursued in the Indian standard, there is no Indian standard on the typical structures. There are no special publications on typical steel structures for the common man. When you make a house, uh, a steel house typically one, two, three, 4 stories should be cheaper today, but it is not happening. You will find in Delhi some 8, 10 story buildings are coming up in steel. And I asked some of my friends who are in this industry that why are you going for steel? So he cited it is now become cheaper. If I add the time cost and I add the total overall cost, it has become cheaper, so I am going for steel. Now that person has his own small industry. So perhaps he's making some saving, and since he has a design know-how, he's able to get that contract. So this is one area I identify, that the standard modular solutions for most of the kind of structures which are coming up underground and others in India, including elevated structures. Standardization, like in our project of the Gujarat Metro, say we make piers, so we make 2 meter dia, 1.8 meter dia, sometimes 2.6 meter dia. But when the contractor will make all these combinations, on paper I can show it is cheaper, but to him it will not be cheaper because he has to tailor made those shutterings, and that shuttering cost in these structures sometimes go up to 40%. It is not a small cost. So if we have a standardization and we have the ready-made solutions, it will be very helpful. Now, third point comes in the limitation. No, it is good to see how we can improve and what we need to do, rather than I go through the things which are so typical and available everywhere. So another is why people are not using. What we are failing to as an engineer or as an industry, why we are failing to identify the things which people want, and what are the limitations why people are using steel to the extent we will like them to use. So one of the thing is the fire resistance. Now second is the durability. Now, other day I was looking for, we make 1.8 meter deep ducts on the underground stations to take the ventilation. So we were looking at a solution, why not to go for steel and do it faster, which will ultimately be cheaper too. Presently, we are doing a prefabricated RCC panel. So we found okay, it meets all the requirements, but there is a problem with the fire requirements. Okay. Now, if there are industry solutions available that okay, with this coating you will attain this fire requirement, 2 hours requirement, 1 hour requirements of not reaching 250 degrees centigrade and things like that. So all these lack of knowledge available. See, one side is the requirement of the item and the requirement of the design knowledge. On another side is the availability. And third comes the interface, whether both people know this is the requirement and this is that. So what I'm saying is that that interaction is actually not so vibrant. That either it is missing or it comes too late in the day to have a confidence that we will be able to do it. Now, third issue comes about the durability. Now, in durability, the in the concrete structures, when they came, they were promoted by the durability better aspects, and then redundancy in the design and the flexibility. Now, what we call as an integrated requirement in the design, when in the initial years of the development in US before First World War, when the Great Depression came and lot of bridges were made, their economy moved on the strength of the infrastructure spending. So they made lot of bridges. Then some around I think 50, 60 years ago, some of the bridges, some of their best bridges collapsed, steel bridge. Now then it came why there is a collapse in all these bridges. Then they found the steel bridges, if a junction fails, then what do we do with it? If one member fails, the entire thing fails. So there were many collapses like this. So then these integrated requirements came. Okay, we design in a manner that if one of the member fails, my structure will not collapse. So these are typically called integrated requirements, not so far embedded in the Indian codes, but they are very much part of the other developed countries' codes now. Now that is also missing. So that puts us in this thing that industry has to take these leads. These are the apprehensions of various people, to use the steel. So the design, as I said, we have IS 800, which has been revised in last 40 years only twice, very minor modifications. The steel may there has been lot of development in steel, but there has been hardly any revision. Junction design is very old method. Is there is not an efficient design. So if industry wants to promote usage at the mass scale, these three, four concerns, durability, fire resistance, availability of design which can be adopted by a common architecture, we have to be alive of this problem that if you want steel to be used in a normal houses, people adopt it, even for outhouses, we have to be alive that there is no Building Safety Act in the country. So when a person designs his office or building, it is not necessary for him to obtain under statutory law a certificate of structural safety. But it is necessary for him to take a bylaws compliance from the municipality registered architect. So that construction is more governed by an architect rather than the structural engineer. So to give the confidence to an architect whose field it is not the design, you need some standard you have to push, convince him this is safe and this is better. So these are various limitations which I have come across, I have seen it. And then these coming to the data center, in case of data center, yes, steel usage as it is 50%. If you make underground structures which is not very deep, then steel is a very beautiful material. If it is very deep, then it will not fit in because soil loads will come into play more than the dynamic load. Dynamic load will reduce and the soil pressure will increase. But the typical data center which will be made in India, they will not be very deep because their requirement is not like for atomic attack, nuclear attack, like Russian railway, Russian metro, which runs at 70 meters, safe for nuclear attack, or Singapore metro, which has 30-meter deep. They are not like that. We are making for the normal nodes, normal things, and in that steel structures are quite efficient. What is lacking is design. Typical designs, design literatures, they are missing. Now there are two things. I unfortunately I didn't get time to make the any presentation, which I will like and which will be useful to the August gathering because in most of the areas you are more you have better knowledge, you have more experience than what I have. Now this from ArcelorMittal Research and Headquarters, what I wanted to show is only one diagram. Okay, recycling of steel in electric arc furnaces. They have shown in electric arc furnaces. I was comparing it with my shuttering and other materials. Most of the material which we use, it goes waste because there is no modular design concepts. So if that comes into, or so there is modular design means like for shuttering also, same design can be fit in 2 meter here, same can be fit in 2 meter, 1 meter also. It can be done. So, but that is not available off the shelf. So people tailor made and waste it. Now, this is like steel sheet piles. Now what happens? People use wooden piles for lesser depth. Why? Because that is cheaper for him. But if it is available in mass, then they will use that steel and steel will be cheap. So this was one. The energy efficiency of course is we know steel is efficient, but another one I will show you. This is a good this. So if we see, the plastic rubber comes at the top, wood products come next, and mineral cement comes above the steel. For the simple reason I explained, the materials which we take from nature and we can't retrieve back their original strength to the maximum, they will obviously tend to be less efficient. And so there is a very good case for steel use, and these three, four things if done, they will help to a great extent. And this, secondly, as I was explaining, As I was explaining, like Tor steel foundation, when the Tor steel came in 80s, at that time, earlier mild steel used to be there. So the Tor steel used to lead to the safer design, more economical design. So good literature came in the market. At present, when the steel grade is increasing, the good literature is not coming into the market. In our phase one project in Ahmedabad metro, when like say our station roofs were being designed with 260 MPa mild steel structure, and many arguments were there, okay, it is cheaper. But we went for 350, we obtained that, and we saved around 10% cost. So that it becomes the environmental friendly also. Okay, thank you very much.